Asimo is a robot created by Honda. It was created in order to encourage and inspire young students to study science. The original design was the EO in 1986, then it went through 11 different designs until it became Asimo. The goal was to create a robot that could exist in human society and help people. This robot is pretty close to being human-like because it can do most things humans can do. The only thing that separates is that it can't think for itself or have emotions. Asimo can do any simple task. It can walk, it can run, it can turn, navigate uneven surfaces, climb stairs, recognize faces, map its environment, and avoid obstacles. It can even pour you a drink if you need it. This picture shows the process Asimo had to go through before it could become the robot it is today. The first three designs, E1, E2, E3, were just basic designs in order to get the movement down. The next three designs, the E4, the E5, and the E6, focused on stair climbing and more on stability. The last three designs, P1, P2, and P3, were all about making it a more friendly design and making it more appealing before it became Asimo. The final model is Asimo. The question now is, what's the next step with robots? Is everyone going to have their own personal robot? Asimo has multiple amazing design aspects, but the most interesting ones to me are how Honda engineers created Asimo's arms 34 degrees of freedom that allows it to do things like turn on light switches, open doors, carry objects, and push carts, and how Honda also uses posture control technology to proactively bend or twist its torso to maintain balance and prevent foot slippage while walking and running, and its walking patterns are generated independently in real time by Asimo itself. Through Asimo, you can see there's a lot of design involved with the robot. The projects have to be redesigned multiple times, and whenever a new goal or need arises, they have to be redesigned to fit those. Another big advancement in technology is the robotic hand. It was developed by the Applied Physics Laboratory at Johns Hopkins University. It is also part of a research project in advanced replacement limbs funded by the U.S. Military Defense Advanced Research Project (ADZ), also known as DARPA. The way the robotic hand works is that electrodes from the prosthetic hand are inserted into the sensory and motor cortex of the person. This allows the person to feel whatever he or she is touching or holding. One of the tests was on a 28-year-old man who had been paralyzed for more than a decade after spinal cord injury. By attaching the prosthetic hand to his sensory and his motor cortexes, he was able to control the hand with his thoughts and able to feel when each finger was touched individually. Being able to control the hand with his thoughts is very important, but being able to feel when each finger was touched is even more important, because this allows you to use a firmer grasp like grabbing a coffee mug and using a lighter grasp when grabbing something soft like an orange. This advancement shows potential for giving people back their limbs, or giving limbs to those who have never had them. The question this brings up though is, are robotic limbs going to allow us to replace any lost body part? Or even how far do we take it before we become robotic ourselves, such as making healthy humans better? The newest version of the robotic hand is called the Bionic hand, which was created in 2010. The Bionic hand is a fully articulating myoelectric hand controlled by muscle contraction. Electronics measure electrical charges on the skin covering the control muscles and command individual actuators in the hand to provide the desired movement. The major design aspect of this hand is that with its lifelike and animatronic design, the fingers move together as the hand closes, so objects such as a fork or piece of paper can be gripped naturally between the fingers. One of the more fascinating aspects of the robotic limb is that now you're becoming more of a cyborg because you're replacing body parts with metal. But then again, it's just going too far, because now we're less human and more robotic.
I've come to Honda's technical studio in Brussels to meet one of their most important representatives, although I'm not quite sure who it is yet. Turns out, who I was about to meet wasn't actually a human, but a robot. Honda's famous humanoid robot, Asimo. Asimo has been designed to interact with humans, so if you reach out your hand, it will shake it. Sensors in its palm detect your touch, while cameras in its head track your movements. Asimo's stabilization technology enables it to react if you upset its balance, moving backwards mid-shake if you push it, or stepping in if you pull it towards you.
Thank you very much.
This latest version of Asimo is the product of almost 3 decades of development. It all started back in 1986 when Honda built a robot which could walk, albeit very slowly and clumsily. In 1988 it was developed to walk more like a human being, and in 1993 a torso was added. By 1996 Honda's robot had become intimidatingly large, so in 1997 it was shrunk to a less threatening size, thankfully before being made autonomous. In 2000, Honda unveiled ASIMO, which stands for Advanced Step in Innovative Mobility. Standing 130 centimetres tall, which is the same height as a seated adult, it's the perfect size for helping out around the home. Over the years, ASIMO has been constantly developed, and it's now mobile enough to play sports. However, it's wise to warm up before any physical exercise, even if you're a robot. And as well as run at 6 miles an hour, ASIMO can walk backwards and hop. You can also kick a ball, so time for a quick robot versus human penalty shootout. That's 1-0 to the Autobots. But is ASIMO as good at saving a shot as it is at taking one? Looks like Honda hasn't trained ASIMO to be a goalkeeper just yet. Football is thirsty work, but thankfully ASIMO can get you some refreshments. With hands that have 13 degrees of freedom, it's able to perform delicate tasks, such as opening a bottle and pouring a drink. This may be unremarkable for a human, but it's an incredible achievement for a robot. In total, ASIMO has 57 degrees of freedom, and this allows it to dance, while its 52-volt battery can keep it going for 40 minutes. Looks like this robot actually has better moves than some humans. Anyway, enough of that. Well, ASIMO, I've got to go now, but it was very nice to meet you, and don't forget to write, okay, or email, or whatever it is that robots do. Click on the video